This is Digital Voices with Bo Tiffany. Inspiring and providing real insight to our listeners with every story. Exploring deep stories behind every guest. Please welcome your host, Bo Tiffany.
Hey, Jimmy. Thanks for coming on Digital Voices. How are you today?
I am great. How is everything with you?
I'm doing great. We're actually hitting 60s up here in Wisconsin where I live. What's the weather
awesome.
down in Austin?
It's like 70 degrees, so, can't complain.
I was looking forward to having this conversation with you today. So your background is in Bitcoin, not only as a investor, but you've also done programming. You've written 3 books on the subject. And that's kind of a big topic these days and has been for, the last close to 10 years at least. So before we kind of get into that, let me get a little bit about your roots. Where are you from originally?
Well, I was born in Korea, South Korea, and I immigrated to the States when I was 8 years old.
Did you go to Texas straight from when you came into the States, or where did you come originally?
I actually was in New Jersey. My dad worked in New York City. And then I went to Michigan for school, went to Boston for a while and did a lot of startups as a programmer. Moved to Texas about 9 years ago. And that I've been here ever since.
I've heard a lot of great things about Texas. You can find almost anything there. It's a big state too.
It is.
Was that kind of surprising moving into that environment, or?
Well, when I was in New Jersey, that was a lot harder since I was 8 years old. But moving to Texas, I did it on purpose because I thought I would fit in a lot better here. And I think I've been right for the most part.
Did you come from a big family or a small family?
Fairly small family. It's just me and my sister and then my parents, of course. But yeah, my interests earlier on, I think like a year after I moved to the States, I begged my dad for a computer. I didn't really even know what those things did. I just wanted one. And I ended up, programming on it like very early. And, I've been kind of addicted to doing that ever, all through high school, some college. And of course, afterwards as a programmer, that's, it's been a part of my life, in a significant way for a long time.
Well, so that's similar to my background too. So I kind of grew up tearing apart the old Commodore 64s and Apple IICs and grew up with the evolution of computers, if you will. How old were you when you first got your first computer, and what year was that? Just to give us some perspective.
I think it was 1986, okay. And I was 9 years old, and it was a Commodore 16. I don't know if you remember that particular model, but it was
I don't.
Much worse than the Commodore 64 because none of the games that work for Commodore 64 work for the 16. So I was stuck with like 3 games.
Sure. Now, you're pretty limited back then, too. It's not like the computers that we have today. I say that for our listeners who might be younger than we are. The games that you had back then were pretty simplistic, especially when you take a look at what we have today. When you started getting into programming, I remember I started doing some DOS stuff. Did you start with DOS, or what were your first steps in the programming field?
So on the Commodore 16, they had a basic interpreter. So you could do some very basic stuff, using basic, 10, and you put the line number and, print whatever. And, you could do loops by doing go-tos and things like that. So that was my first exposure was, programming basic on the Commodore 16. It wasn't until middle school when my dad got an IBM. Well, it was a PC clone. It was manufactured by Hyundai, but it was an 8086. And the DOS was on there. Some spreadsheet program was on there, and there was some basic interpreter on there too. So I programmed a little bit on that and learned about some DOS shell programming, which honestly wasn't that powerful back then. But yeah, that would be like the next thing. And then high school was when I had a 486 and I was taking a class, like a computer programming class in high school, and the programming language is Pascal. So I had a Pascal, programming environment, and programmed in that during high school, and eventually went over to C, C++, Perl, Python, and many other languages. But that was more, after college and so on.
And a lot of those languages are built on other languages like DOS and such, and there's a relationship in between them too. Can you kind of give us an overall perspective of how programming languages work?
Well, so you write it in sort of the programming language, which could be like Pascal Basic or whatever. Nobody really uses Pascal anymore. I think there's some people that use Visual Basic, which is sort of like a derivative on using Excel and things like that. C and C++ are obviously still around. They're, more modern languages or whatever, but that's what you actually program in. And then in general, it gets compiled in some way so that the computer can understand it. And usually there's a compiler or, some sort of program that will run the code for you, whether it's interpreted or compiled. There's usually some binary or program on the disk that will run them, and then you get to see the execution of your program. Now there are different GUI environments that you can program in and so on. But like for me, at least back then, it was just all command line everything. It was just okay, take some input from the user using board, and then it'll figure it out. A lot of the programming languages had like OS level calls to do a lot of that. So getting input from the user requires some sort of read from the input, which the programming environment will figure out based on the OS that it's on and so on. So there's a lot of interaction there. But like programming proper, I think, is just writing up the code and doing things like that, and then letting the the binary or the program that interprets that code or compiles that code and then runs it to actually execute it.
So for you, this started early on, and these are kind of foundational pillars for what you went into. Were there any computer science classes in your school that early on? I mean, we're in the 80s, so we're still in the infancy. I'm not sure what they offered, but anything that kind of spurred you in that direction externally?
Yeah, I think there were like these Saturday classes that there would be one guy teaching karate, another guy teaching like how to play tennis, like for kids, right? Like when I was 10, 11, 12 years old. And there was one for computer programming that I took. And then my mom recognized that I really liked, playing with computers and so on. So she managed to find a college graduate who could teach me stuff. So she actually got me lessons, and we went twice a week, and she showed me some stuff that you could do in BASIC that I didn't really know that you could do, like variables and things like that, which, I played with. And, the woman that taught me just was like, okay, yeah, now you can do this, you can do this. That eventually led to, taking more computer programming classes in high school, where it was a little bit more of a formal education, big O notation, and analyzing various data structures and things like that. But, it was sort of an affinity that I kind of had, and they didn't really have YouTube back then. So we had to make do with what we had. They didn't really even have that many good books. So it was it was a lot of just searching around in the dark. Let's see if we know anybody, and maybe they can teach something. So I found my way, but it wasn't a clear cut path like a lot of kids have nowadays.
Right. Well, and you were in a new field, interested in a new field, kind of developing with that technology, just like I did. Previous to us, those computers were the size of a warehouse, and so when like the Commodores and such came out, it opened up a world that was unavailable to the average consumer, and it's just grown from there. One of the things that I find interesting is that you had a natural affinity for this. Was there anybody external that kind of helped push you into some of these areas, or did you just kind of follow whatever your heart and mind led you to in terms of programming?
I just kind of did whatever, and I tried to figure out new ways of doing things, and making cool. Like I figured out at one point that I can program the Commodore 16 to like draw stuff on the screen. So I made like these pretty math graph things and things like that. It was just like I like tinkering and making things. I think I've always sort of had that kind of personality, and the computer was my canvas and I was the artist or something like that. And that was, for me I don't know. It was something that I could do that I enjoyed. And I quickly realized that this would become a much bigger thing later. And I think my parents saw that too. And they just sort of encouraged me and, found the resources that would help me. I mean, they got me a 486 when I was in high school. And I think back then it cost like $2,500 for a 486. Yeah. And that was, their way of saying, okay, we know you like this stuff. We're going to, help you with it. And at the time, that was the fastest computer that you could get. I think it had like an Intel 486 chip, like 66 megahertz or something like that. And that was considered insanely fast.
Right.
I was obviously playing a lot of games on it too, but there was a good deal of programming that I just enjoyed. And, I've been a math guy for a long time. So it sort of naturally fit into what I enjoyed and what I thought was interesting and so on.
So tell us, how does math fit into programming? I always heard that programming is based on math. So if you're not good at math, you're probably not going to be good at programming. How does that work?
Yeah, that's a good question. A lot of math is actually kind of figuring out, different aspects from, a limited set of information, right? Like you get at least like the math competition problems or whatever. It's just sort of like, here's the data that we're going to give you. Figure out this other piece of data that we want, or something like that.
Sure.
And the trick is kind of like going through a process where you come from these inputs and getting that output. Programming is very much like that in many ways. And there's a lot of synergies between the two, because using programs, you can like solve a lot of math stuff. Using math, you can speed up a lot of programs and things like that. So
you're talking about simulations?
It uses the same circuits or something like that, and it uses the same part of the brain.
When you're talking about speeding up, and again, this is for my listeners, you're talking more like running simulations and things?
Well, so for certain math problems, it's going to be very hard to brute force, right? Like you're not going to be able to do 1,000 different multiplications in any short amount of time. But using a computer, you could do that in like a microsecond or something.
Right.
So, a lot of like mathematicians actually like will program different things so they can find out the answers to some questions before they actually prove it and so on. And that's a big part of mathematics these days, is that you can actually kind of know the answer to a question you might have with like 99.9% probability, and using computers as an aid. And similarly, like if you're a computer programmer, having some math background and, formal computer science is a lot of proving that your program is going to do what it says and so on. So, the two disciplines, at least for me, are intricately linked, and they've been pushing each other in many ways and helping each other advance. So, a lot of mathematics has benefited from computer science. There was a problem that I work with a professor in college for, and it's called the Kepler conjecture, which is, the packing of spheres in three-dimensional space. And he had used some computers to figure out that, you only need to cover this much, these many cases, and then you can prove that the Kepler conjecture is true. And it took him a long time, but he eventually did prove the Kepler conjecture in part by using computers to do that. And similarly, computers, computer programming has benefited quite a bit from a lot of mathematical breakthroughs. I think the most obvious are like RSA, ECDSA, Diffie-Hellman exchange. A lot of cryptography essentially came from mathematics and group theory. A lot of using that, we were able to program these things that essentially ended up being kind of like very useful computer science devices, like public key cryptography, for example, which ultimately, led to the creation of Bitcoin and lots of other things, secure websites and, the fact that you can go into your bank account and not have people in the middle be able to listen in and so on. These are all sort of like enabled to some degree by math. So, there's a lot of synergies between the two, and one pushes the other. They've both mutually benefited quite a bit.
Yeah. Thank you for that. I think that was very enlightening for our listeners. There is, like you said, a synergy between computer programming and mathematics. And so as you started, you went into college right out of high school, or did you take a little time off?
Nope, I went straight.
And I should ask one last question I wanted to, your sister, is she also a programmer? Is she into computers?
Oh, no, she's not. She's a lawyer, okay. And she's actually not like in that area at all. It was just me, and I don't know. Like some of my kids like programming, but others don't. So I think it's kind of almost random in some ways.
Yeah, your personal strengths, and this is suited to yours. In college, obviously that was an eye-opening experience. I'm assuming that you were exposed to a lot more in terms of opportunities to learn various new programming languages and maybe how to use those. What were those beginning steps like for you?
Well, college, I was actually a math major, and I didn't program all that much because most of what I was doing was, just straight math. Like it was, proving various things, and I wanted to be a math professor at that point. And it was exposure to that professor that was trying to prove the Kepler conjecture that I realized, okay, well, like there is some use of programming in a lot of this modern math. And it wasn't really until my friend from high school contacted me because he wanted me to work for a startup that he was like, hey, you used to program back in high school. I was wondering if you were interested in joining my startup. And I was like, yeah, sure. I mean, like this was right around the .com boom. And so, he offered that to me, and I was like, yeah, sure. And he's like, well, can you prove that you can program in some modern languages? And I was like, I guess so. I can go learn. I don't think it'd be that hard. So he gave me a programming problem. So I took like a week to go learn C and C++ and code this thing at the same time, which in itself was very interesting. At the time, like object-oriented programming was kind of new. I didn't really know it. So I programmed it very procedurally. But it was good enough that he ended up saying, "Come join me at my startup in Cambridge." So I went over there like a week later. Packed up all my stuff from Michigan and drove to Boston. And joined the startup as like employee number 6. I think I was the only non-Harvard guy there, so it was that in itself was an interesting experience.
Yeah.
And of course, like the first thing he says is, "Okay, now that you've learned C, I want you to learn this other language, and it's called Perl." And that's what I did for 2 weeks, and I started writing code into that code base, and started learning the art of software engineering, which I found out is nothing like what they teach you at school. And yeah, it was a very interesting time. And yeah, the last 23 years that I've been a programmer, so it's brought a lot of different languages in. I don't know. I feel like I've programmed in pretty much like most popular languages that have existed, like Java and like random stuff like Tickle and Python and JavaScript. And, I think I played with Lisp and Rust and PHP, like just pretty much any language that's been out there, high level, low level, I've ended up playing with. Not necessarily because the job demanded it, but because, I wanted to see how different things worked and what the features were and so on.
So I wanted to touch on 2 things. One is I feel like you're a savant because most people cannot pick up C in a week or Perl in 2 weeks. Obviously, some of it's built on what you've learned already, but that's still pretty impressive. Number 2, you had said that the programming field was not like what they had told you it would be in school. Could you explain that to our listeners?
Yeah, I mean, I think I had a really good foundation on programming because I had been doing it for such a long time. The ages between 8 and 18 or 9 and 18, the 9 years, like elementary school, middle school, high school, where I played with all that stuff, that was still, good experience. I at least knew, like some command line stuff, and it wasn't that hard to transition to Linux because, I knew some commands in DOS and stuff like that. And I found out later that they were, similar. And it was similar with programming languages. You have loops. The loop structure, the syntax might be different, but they're still the same loops. It's not like it's that different. And most of it was just getting the computer program to compile. It was, okay, you got this syntax wrong. You forgot a semicolon here. You forgot, to put this there and whatever. Perl was a little bit challenging because I had to learn regular expressions, which is in itself like a whole new language. But like picking it up, I feel like, okay, well, this isn't that different than what I did in high school. It's just actually a lot cleaner and easier to do, or picking up C or whatever. Like it really wasn't. Like there's comes a point where you've learned enough about like just computer programming in general, where picking up a new language isn't that difficult. And, it's more a matter of syntax and learning sort of like the idioms of that particular language than anything else. And now the other half of your question is about the art of software engineering. And this is something that took me a few years to really grasp. And it has to do with, like sort of the discipline of software engineering. Most people think that it's all coding. Coding, I would say, is at most like 25% of it. There's a significant amount of other things like testing, unit tests, documentation, a source control, design, and things like that, user interfaces. Like there's a lot of things that go into the art of software engineering that you just, you need to pick up. in order to actually be a good software engineer. So, I mean, if I asked somebody out of school how to, create a linked list or something, I'm sure they can do it. It's not that hard, and it's something that they teach you pretty explicitly in school. But programming an application that's scalable, that's tested, that's not going to have that many bugs, that's easier for another developer to go in and change if needed, to add new features, that's extensible, that doesn't waste resources, that connects to other services in a reasonable way, and things like that. Those are all sort of like the trade-offs that you kind of have to learn as a software engineer. And also like just working with other software engineers. Like that's not easy. Like a lot of the assignments that you get in college or high school are very solo. So you just go, okay, well, I'll tinker with it until it happens. It's a completely different ballgame once you're working on a team and you got people like stepping on each other's toes in code and stuff like that. And you have to look at what the other person did and read their code and see what it did and see how it affects whatever you're doing. These are all skills that you have to learn. So, one of the things I realized that like experienced programmers can get, which inexperienced programmers don't get, is the ability to debug quickly. So I've gotten to the point where I've seen so much bad code that I have like sort of like natural instincts on what could be wrong, right?
Sure.
Like if something goes wrong and it's okay, it errored in this way or it's doing this or that, I know what to look for and say, okay, well, here's probably where things are going wrong or off the rails or whatever, or here are the 5 different places that it could be. Let's go check each one. Whereas a new developer that's out of school will be kind of like, okay, something went wrong. Somebody please help me. I don't know what's going on. Like they haven't developed a lot of those instincts because they don't have those tools. They probably haven't learned good software programming practices like writing unit tests and making sure that everything works and checking in small bits at a time into source control or having code review, having your code reviewed and things like that. There's a whole art to it that isn't really appreciated by the people that maybe come out of school and just don't know. I mean, I've heard that some other computer science programs are starting to teach a lot of this stuff, but this was one of my all-time highest liked tweets was things that they should teach in school but don't for computer programmers, and I listed a lot of that stuff and. Some people replied and said, hey, actually, my school's starting to teach me some of this. And, I think a lot of the coding boot camps, for example, are a lot better about this stuff because they're doing it for the sake of getting these people hired. And these are very important skills for people to have.
When it comes to someone that's younger, perhaps might be listening to this or their parents are, what are good foundational pillars for a young person that wants to get into a comp sci field or programming field? What are the essentials that they need to kind of get underneath their belt in order to be successful?
Yeah, the big thing is the ability to learn on your own, which honestly a lot of people don't have because they have like 12 years of school where they force you to learn and they don't necessarily learn on their own.
Sure.
And this for me is the thing that separates really good like decent programmers from really good programmers is the ability to just go out there and be like, okay, well, I want to go learn this thing and I'm going to take a few weeks and just go read about it and program with it, tinker with it and just try it. And if you don't have that natural curiosity and drive to go learn something on your own, you're probably not going to be a very good programmer. I mean, you'll still make decent money probably doing, something for a corporation that needs some back-end app for, to make 3 people's jobs more efficient or something like that. But to be a real programmer that understands what's going on and it is really good at their job, you're going to need some level of curiosity, natural curiosity, and the ability to learn that stuff on your own and not needing say somebody that's hovering over you to, or like kind of forcing it down your throat or whatever. And that, I think, ultimately is like a matter of discipline or curiosity or some combination that honestly, like a lot of people kind of lack.
Yeah. Well, let's say you're a noob, but you have that drive and that self-learning interest. What are the first? What would be the first? You want to have an introduction to programming. You should look into Perl, or you should look into C, or like what would be the first thing for someone that just is no background, just an affinity for it, maybe a knack for math and an interest. Where's the first thing they should look at just to get a feel for?
I would say that introduction to programming, you can go to something like Python for Everybody. So I think it's like pi4e.org. Okay. And it's just a bunch of lectures for like people that don't know any programming. And, it goes through like how to download the Python interpreter and get an editor set up and, start like writing something into the editor that looks like Python and, like execute some programs and things like that. It just goes through very slowly. Like, okay, here's what programming is. Here's some things that you can do with it, and then from there, if that's interesting and if you enjoy it, then you can go and do more stuff. And honestly, a lot of programming is hooking into like a lot of other technology that people have already built. So, for example, making an app for your phone is essentially hooking into the APIs that the developers of the phone operating systems have already made available for you. So, with Apple, it's like in Swift, and they have different UI elements that you can pop up, or pixels or images that you can bring up or whatever, different controls like buttons and, calendar widgets and things like that you can add. And it's a matter of learning all of that and being able to recall that when you need it, or to go look it up when you need it. That it all comes down to. And it's, like if you don't like that process of learning, then you're going to have a really rough time, because almost anything that a programmer does, there's components that you're just not going to know. It's not going to be, okay, I already know everything I need to know and I'm just going to do it. I mean, There are people that do that, right? Like that like build the same thing over and over. Generally those tend to become pretty commoditized. So for example, there are people that will help you set up a website and they know WordPress and PHP. So they just sort of like do everything for you. And they do the same thing over and over again. They already have their toolbox set. With programming, what you're gonna need to do almost on a constant basis is add new tools to your toolbox. And that means going and learning. Okay, well, I don't know much about TensorFlow or whatever. Let's go and learn what that is and how to use it and why it's useful. There's this new thing called GPT-3. Let's how do I hook that in or make that useful? I want to make a bot for my Slack channel. Like how do I do that? What do I hook into? I want to make a Twitter bot account so I can do this, that, or the other. How do I, there are all sorts of things like that where most of what you need to do isn't the actual, big O, N running, algorithm to sort something faster or something like that. It's almost always like, okay, here's a new API and you need to go hook into it and make it do something that that you want it to do. But all of that is kind of unfamiliar to you. You have to go look up documentation, read it, and figure out how you're supposed to call it, and how to get like developer token, API tokens, and hook that up and make sure you authenticate properly and there's just these are sort of like the practical steps. Sure. And in order to get used to doing all of that, you just need to be curious and be willing to learn almost on a constant basis.
I appreciate that. I think our listeners, got some insight from that too. So when you got out of college, you got in with your friend at the startup. I was looking at the step where you went from there and then how you got into being a Bitcoin expert.
Okay. Yeah. I mean, I did startups for a while. So that first startup did okay, but ultimately, it expanded to like 150 people. And then, the market started crashing. No one was buying. So, there were like 3 rounds of layoffs and I finally got cut. I did another startup fairly soon after that. It was Athena Health, which was a healthcare company. They're public now, and they went public while I was there. Then I did another startup after that. Well, I've just been doing startups for a long time, and eventually I got to a company here in Austin, and I was working at Retail Me Not when Bitcoin programming became more of a thing, and somebody was hiring people to work on an open source project, and was paying in Bitcoin. And that was for me the main attraction, was that I could get paid in Bitcoin to work on something that I, like work as a programmer, which I already knew how to do.
What year are we talking?
This was 2013. So
okay.
This was as the market was going up. So this was like October 2013. October 1st, I think Bitcoin was at $100. I think November 20th, 2013, it was at $1,100. So it went up really quickly around that time. So it was very exciting for me to work on something, on something Bitcoin related and get paid in Bitcoin. So, I started doing that. And the guy actually was out of the Ukraine and he was paying me in Bitcoin. So the guys in the Ukraine paying me in Bitcoin, and I'm sitting here in Austin, and doing that. And, I don't know if you remember 2013, but Vladimir Putin, like invaded the country, because of, some weird things that were going on. And my, the guy that was paying me kind of went offline for like 5 days. I still remember, I think it was November of 2013. And he came back. He's like, yeah, sorry. Putin kind of, screwed things up here and I didn't have internet access. But that's how I got into Bitcoin programming, was through an open source project that I was contributing to. That made me realize like I should really get into this, because I'm way more passionate about Bitcoin than I was about, the company I was working at that time, Retail Me Not. And that led to an opportunity at a sort of like Bitcoin adjacent company called Monetas, and they were doing some stuff, and they agreed to hire me, and they were based out of Switzerland. I did some work for them. Then I moved on to Armory, which was a Bitcoin wallet startup, and did a bunch of stuff with them. I was VP of engineering.
Let me ask a question real quick. So we're talking about Bitcoin, and what we're really talking about is blockchain technology. And I have so many of my listeners that probably aren't very familiar with blockchain technology, as they're very confused still about Bitcoin. They know that it's becoming more predominant. They're a little familiar with it, but can you give us some more background on what Bitcoin is and what it's based on, and why it's the upcoming currency model, if you will?
Well, Bitcoin is the easiest way to describe it is as digital gold. It's money that is decentralized and digital, and this usually blows people's minds because for them, their mental model of digital things is either something like an MP3 file, which can be copied perfectly with perfectly an infinite number of times. Or it's something like concert tickets or online coupons or, World of Warcraft gold or something, where it's controlled by a central party, but it's limited in supply because it's controlled by that central party. What Bitcoin it's an innovation that adds decentralization and digitization, which is kind of remarkable. We didn't know that was possible until 2008 when Satoshi Nakamoto invented it. But essentially, it means that it's a digitally scarce resource that's not controlled by a single party. And this is why we call it digital gold. Gold, for example, in the physical world is decentralized. Nobody controls the issuance of gold, right? There's no central bank that says, okay, here's how much gold that we're going to add to the world. Right. Anyone with a shovel and some land can go and dig for gold. And in fact, many do. There are lots of gold mining companies that exist that go and search for gold underground or wherever. But you don't need anyone's permission to do it. You just need land and some equipment to go do that. Now I could go dig for gold in my backyard, but I'm not likely to go find much because, I don't happen to live over a gold mine. But if you do live over a gold mine, then it's going to be a lot easier for you.
Right.
So in the same way, Bitcoin is like digital gold in the sense that there are sort of these rare things that you can find, and that process in Bitcoin is also called mining. And I'm told that in gold mining, you need to process about 40 tons of dirt and rock in order to find 1 ounce of gold, which is a tremendous amount of stuff to sift through before you find the 1 ounce. Bitcoin mining is similar, except instead of dirt and rock, it's processing lots and lots of numbers. So there's literally trillions, quadrillions, many numbers that it goes through before it finds essentially that ounce of gold or what we in Bitcoin call proof of work. So that's how Bitcoin is like actually created, and it's produced and so on. It's essentially decentralized digital. And in addition to it being decentral and digital, it's also perfectly scarce. So there will never be more than 21 million Bitcoin in the world. And this is because of the software that runs it. And it has a monetary policy that is utterly predictable, unlike the monetary policy of the Fed or whatever. And it's unique in that regard. And that means that we have a lot more certainty about the nature of Bitcoin and the scarcity of Bitcoin going forward, unlike with a lot of other commodities. Even gold, which has lasted 6,000 years in large part because, like in any given year, nobody finds more than like 2% of the entire gold supply that exists. Mm-hmm. That's not the case with like a lot of other commodities. Like salt used to be money until somebody figured out how to produce enormous quantities of salt. Glass used to be money. Seashells used to be money. Rye stones used to be money. All of these things stop being money as soon as somebody figures out how to produce a lot of them at scale. They haven't figured that out for gold, but it's not out of the realm of possibility. For example, NASA found an asteroid in 2019 which had more gold in it than all of the above ground gold that exists. So if they could figure out some way to harvest that asteroid for lots and lots of gold, or if that asteroid should like crash down to Earth or something like that, there would be way more gold, and it would sort of destroy gold's value because it wouldn't be scarce anymore. Mm-hmm. But with Bitcoin, it is perfectly scarce. There will never be more than 21 million. So there's a certainty about Bitcoin that doesn't exist with any other, that hasn't ever existed with any other money. So that's sort of like the innovation that Bitcoin brings, is that it's not necessarily, it is technologically driven, but ultimately it's a new money, and it's a way better money than anything that we've had before.
Yeah. I have a question. So I know that with Bitcoin, the longer the blockchain, the more processing and the more power that's required in order to mine. How does that affect? Well,
it's not quite like that. It's okay. More, however many miners are on the network, the software makes sure that blocks are found about every 10 minutes. So if like another so right now, say there's like 1,000 miners. That's not exactly true, but
Sure.
say there's 1,000 miners and another 1,000 miners like just came into the network. What would happen? Essentially, there's something called the difficult adjustment algorithm in Bitcoin, which after 2 weeks, it takes the extra 1,000 miners into account and says, okay, now we're going to make proof of work more difficult so that we still get blocks every 10 minutes. But if, like, say there was 1,000 miners and 500 of them left for various reasons, maybe the Bitcoin price went down or something like that, then after 2 weeks, during the difficulty adjustment, it would make proof of work finding easier so that it would still be about 10 minutes. So with something like gold, it's like the difficulty is just in going and finding it. With Bitcoin, it's finely tunable. So with gold, it's about 40 tons of dirt and rock. I think it was less in the past, but because we've been like gold so valuable and the technology has been getting better, it's trended towards about 40 tons. That the amount of processing necessary to find that proof of work is adjustable by the software, and that's ultimately how that works.
This might be a good time to explain blockchain technology. Can you kind of give us an overview of that?
Yeah, blockchain is sort of a buzzword right now, and honestly, most people that say the word blockchain, you should be very wary of because they're usually selling stuff that they don't know what they're talking about. But essentially, a blockchain is what it sounds like. It's a chain of blocks, and a block is essentially a group of transactions. So, you can think of Bitcoin's blockchain as a giant ledger, and it is the ledger of every transaction that's ever happened in Bitcoin. And a block is a group of transactions that get sort of added to the ledger every 10 minutes. So a blockchain is literally a chain of blocks, and they are chained together like a linked list. One comes after the other, and there's an ordering to it. So another way to think about it is it's a database of transactions that have some ordering to them. And that helps us, defeat the double spending problem and so on. But it's really not that complicated. It's just a group of transactions, and it's every transaction that's ever happened on Bitcoin. And every 10 minutes, a new page gets inserted into the ledger, more or less. And it has to contain proof of work, which makes it very, very difficult to go and replace that page. If you wanted to replace that page, you have to expend the same amount of energy in order to replace it. And you would be better off just adding another page to it instead of trying to replace the page that's currently there.
Sure. I know that because of the technology, there's quite a bit of security within that exchange. It's been in recent years, though, we've heard a little bit about hacking of like the Bitcoin exchange and things like that. Can you explain how that is? Are we becoming vulnerable, or is Bitcoin technology becoming vulnerable to hacks, or is it just the exchange aspect of it?
Yeah, it's the exchange aspect of it. At a protocol level, it's been very, very solid. No one's actually hacked the protocol per se. What people have been able to do is because Bitcoin works on public key cryptography. Essentially, if you own the private key, you own the Bitcoin. So whatever private key that the coins are in the ledger say that they belong to, you have the ability to spend that coin, and that means that you actually own it. So if you don't secure the private key properly, and somebody steals your private key, you've essentially lost your Bitcoin. It's kind of like holding a gold bar in your house and somebody coming and taking that gold bar away. Well, that means that you've lost it. That doesn't mean that gold itself is a bad money. It just means that like you weren't very good at securing your gold bar. Mm-hmm. And that's what a lot of these exchanges have done. And, like Bitcoin tends to be the target of hackers because it's very liquid. And it is very, like it's if it's connected to the internet, then you don't really have to leave your house to try to hack it and stuff. So it does become sort of like that. And a lot of exchanges have to put a lot of money into security because it is so difficult to secure properly and so on.
Are the exchanges insured? I know, like, for instance, a bank would have some FICA insurance. How does it work for Bitcoin? Is there any protection for the exchange?
Yeah, so a lot of exchanges are insured. Some of them are not, but it really depends on what they're insured for as well. They might be insured from, like, attacks against the coins that they're holding, but they're not necessarily insured against, somebody spoofing as you and manage to just to get into your account and withdraw some Bitcoins on your behalf or something like that. That they're probably not insured against. So, it varies the amount of insurance, and insurance companies are getting used to this too, and they don't necessarily know what needs to be done and or like what the space is. So it's taken some time, but they are getting on board.
Sure. And this is a trend that we're moving towards. I think the price of Bitcoin right now is over 16,000. Where is it at right now?
Oh, it's way more than 16,000.
Okay, so it's been
it's currently 54,000.
Holy cow. So I looked like less than a year ago, and I think it was around 16. So there's been an explosion within the Bitcoin price. That's amazing. I think that's proof in the pudding that this is going to stay. I know that Bitcoin as a market has been really volatile. Can you explain a little bit about that? Because that's made a lot of my friends that wanted to invest in Bitcoin apprehensive because of the volatility of the market.
Yeah, I mean, this is the thing that everyone wants in the market. They want zero volatility and high reward, but that's they're kind of same two sides of the same coin. If you want low risk, then you're going to get a very low return. So you can put your money into treasuries. I think the 10-year treasury is at like 1.6%, and you'll get 1.6% of reward. But if you want higher rewards, then you're going to have to take more risk, and risk, at least from a market perspective, comes out as volatility. And obviously, Bitcoin has a tremendous reward. I think over the last 10 years, the average annual return the annualized return is something like 200%. So you're going to see a lot more volatility in Bitcoin just because it's an asset that's going up a lot. What you're not going to get is a slow and steady rise that's utterly predictable, because that means that essentially there's no risk and there's a lot of reward. There's no asset in the world like that. There's lots of assets that have low risk and low reward. There are some assets like Bitcoin, pretty much only Bitcoin, that's very high risk and very high reward, meaning high volatility. Maybe there's some other things like that. But I mean, you're not going to get low risk and high reward. So like, from an asset allocation standpoint, I think it deserves at least a small portion of your portfolio, depending on what your goals are. But what you're not going to get is a steady high return. You either get a steady low return or a volatile high return, and that's just reality.
Sure. I think that there's something to be said, and you could probably tell us a little bit about this too, which is Bitcoin is decentralized, as you mentioned. Governments have had a large issue with that as a result, but there's been some changing trends. Yeah,
I mean, there's a lot more politicians that are pro Bitcoin. I think they recognize that it is a very good store of value. Cynthia Lummis from Wyoming, she's a senator. She's a known Bitcoin holder, and she's trying to champion Bitcoin in the Senate. Warren Davidson from Ohio. There's Patrick McHenry for North Carolina. Several others probably that are very Bitcoin friendly and recognize the role that Bitcoin has in freedom and so on, especially from a financial perspective. That said, I don't know of a single country that's holding Bitcoin as a reserve asset like they do gold or US dollars or something like that. Though I don't think that's that far away. What we are seeing are a lot of corporations that are starting to use Bitcoin as a treasury asset. So MicroStrategies has done that with their treasuries. I think they've converted $450 million of their treasuries into Bitcoin, and then they've done two convertible note offerings, which they've used to buy Bitcoin as well. Tesla has bought $1.5 billion worth of Bitcoin for their treasuries. There was a Norwegian oil company that also bought some Bitcoin for their treasuries and so on. So this seems to be a trend. They're recognizing that the dollar is fast expanding and that inflation is coming, and this is their hedge against it. At some point, central banks will also recognize that and get on board, but as of now, I haven't heard of any of them doing that. There is a trend towards maybe doing something like central bank digital currencies, but I don't see that as that related to Bitcoin. For me, that's more about upgrading the infrastructure around the different sovereign currencies that exist. In large part, I suspect to cut out commercial and retail banks and have a relationship with the citizen like directly by having every citizen have an account with the central bank, something to that effect, which would reduce some friction and make financial policy making from a central bank perspective a lot easier. But yeah, those are the trends that I see. I don't know if that's what you were looking for.
It was. And that kind of was leading me into this last segment, which is you've written 3 books on Bitcoin, and you have probably more experience than anybody else that I've ever come across because of your background programming. You have a knowledge that you're bringing to the table that I think is really valuable. The books that you've written, can you tell us about them?
Yeah, so I have 3 books. The first one is Programming Bitcoin, and that one was published with O'Reilly. O'Reilly, if you are not familiar, is sort of the premier technical book publisher, at least in the United States and in many countries abroad as well. The book's been translated to 4 or 5 different languages. I think Chinese, Japanese, Korean, Russian, and Polish. I think, but yeah, there's a bunch of like technical details in there. It's meant for programmers to learn the Bitcoin protocol. This is the resource that I wish I had when I was learning Bitcoin. And it has a lot of different exercises and so on. So if you're a programmer and want to learn Bitcoin, that's the book for you, Programming Bitcoin. The second book is the Little Bitcoin book, and I wrote that with 7 other people in a week. And that was a really fun project, and it's a book meant to give you a very quick overview of Bitcoin if you have no idea what it is. First chapter is all about, what's wrong with the current system and like sort of the monetary regime that we live under. And then we get into the technical details of Bitcoin, its price, its volatility, and surprisingly how it matters for human rights. So, that's the Little Bitcoin book. It's a very quick read as a way to learn about Bitcoin for those that don't know anything about it. And then finally, the third book is Thank God for Bitcoin. I also wrote this with 7 other authors, although we didn't write it in a week. We wrote it over COVID. And essentially, the book makes the moral argument for Bitcoin and does so from a Christian perspective. The idea being that we're under a very corrupt and immoral monetary system, and that's the argument that we make for the first 7 chapters. Going through the history of money, the theology of money, the inflation and fiat money, and what that does to politics, our individual sort of lives and incentives, and even the church. And then finally, we talk about what Bitcoin does, how it fixes a lot of the ills that we find in society as a result of fiat money, and finally, how Bitcoin fixes a lot of that. And those are the 3 books. They're all available on Amazon. Programming Bitcoin, The Little Bitcoin Book, and Thank God for Bitcoin.
Excellent. I will put links in the description to the Amazon site as well for those books.
This has been Digital Voices with Bo Tiffany, exploring deep stories from real-life guests with real-life experiences, providing insight to our listeners with every story. Stay up to date on future podcasts by bookmarking Digital Voices with Bo Tiffany.podbean.com and follow Bo on social media by searching Digital Voices with Bo Tiffany. Have an idea for a future story? Send your idea to acrmadison@gmail.com. Until next time, grab life by the horns and keep inspiring others.